Hello and welcome to the Spring Security video. Understand BCrypt Password Encoder with me, Nam Hà Minh from CodeJava.net. In this video, I will help you understand about BCrypt cryptography algorithm and how to use the BCrypt Password Encoder in a Spring Boot project with Spring Security. So, what is BCrypt? BCrypt is a password hashing function based on Profit, a symmetric key block cipher algorithm, and crypt, which is a password hashing function in Unix. And BCrypt is high secure because assault is used to protect against rainbow table attacks, and it is adaptive hashing function. The cryptographic strength can be increased when computer hardware gets faster. That means the hashing function can be configured to run slower, which also means it can slow down attacks. Now let's understand the BCrypt algorithm with some pseudocode. Suppose that we want to generate hash value for a given password. So the input of the algorithm is the cost or the strength of the algorithm, a sort, and a given password. And then it initializes the state by setting up an expensive key using a Blowfish algorithm for the cost, sort, and password. And then a ciphertext is chosen with this magic value, and then the ciphertext is encrypted repeatedly 64 times. And finally, it returns the hash string is a concatenation of the cost, sort, and ciphertext. That means for a given password, the BCrypt algorithm produced a hash string, which is a result of encrypting the magic text here 64 times using Blowfish with the private key is a given password. That also means the password itself is not encrypted or hashed. It is used as a private key to hash this magic value 64 times. Now let's understand format of the hash string produced by BCrypt. The prefix is a version and followed by a dollar sign and the strength of the algorithm dollar sign, and the next 22 characters is a sort, and the last 31 characters is the hash value of the magic ciphertext. Here's an example of a hash string produced by BCrypt. As you can see, the version number is $2A, the strength or the cost is 10, and these characters as a sort, and these characters as a hash value of the magic ciphertext. And the versions can be $2A, $2B, $2Y. The strength or the cost of the algorithm ranging from 4 to 31. The higher the strength, the more computation power it needs to generate the hash string. And the size of the sort is 128 bit by 64 encoded to 22 characters. The size of the hash is 192 bits by 64 encoded to 31 characters. So the total length of the hash string produced by BCrypt is 64 characters. So when designing a column in the database, make sure that the size of the data type of the column is equal or greater than 60 characters. Let me show you some other examples of BCrypt hash string that are stored in database here. You can see in the customers table, the password column stores the hash values of customers passwords here. You can see. Let's understand how Spring Security supports for BCrypt. In order to use BCrypt password encoder in a Spring Boot project, we need to import classes from this package or .springbootwork.security.crypto.bcrypt, and the API class is BCrypt password encoder. We use this class to encode a raw password into a hash string, and we also use this class to verify a raw password against an encoded value. And the algorithm implementation class is BCrypt This class is used by the BCryptPasswordEncoder class, and for the versions of the BCrypt algorithm, Spring Security defines the enum BCrypt version inside the BCryptPasswordEncoder class. And in Spring Security, the default strength of BCrypt algorithm is 10. The sort is random, and the default version is $2a. Now I'm going to show you some code examples with BCrypt password encoder in the Spring Boot project. You see, this is a Spring Boot project in Spring Tools with IDE, and in order to use BCrypt password encoder in a Spring Boot project, you need to have this Spring Security dependency available in the project class path, Spring Boot Starter Security. Now let me create a new test class here. BCrypt test. I will write a JUnit test to encode a very simple raw password. Encode password. I want to encode this raw password in Java 2020. So I create a new instance of the BCrypt password encoder class. Password encoder equal to new password encoder. And as you can see, there are several constructors of BCrypt password encoder. The default no argument constructor, or use the constructor that allows us to specify the version, the strength. Here I use the no argument constructor, so it will use the strength is 10 and the version is $2a, and then I encode the raw password. Encoded password equal password encoder. Encode raw password and print the encoded password to the standard output. So the encode method is used to generate hash string value for a given password. Now let me run this test method. And you see it prints the hash value here. You can see the version number $2a, strength 10, and followed by the sort and then the actual hash value. So it's very quick, right? With the default strength 10 here. And when using a password encoder in Spring Security, you can use the method matches to verify a raw password against an encoded value. Here, matches. I want to verify this raw password Java 2020 with the encoded password, and this matches method returns a boolean value. Boolean matched here, and I assert true for the value of the variable match here. Matched here. Okay. And run this test method again, and note that the sort used by the BCrypt algorithm is random. So given the same password, if you run this test method again, you will see the value of the hash string will be different. Now let me run this test method again. Okay, and you can see now the hash string is different, right? Now let me modify the code to create a new instance of BCrypt password encoder with a specified version and strength number. I want to use this constructor passing the BCrypt version. I want to use the version $2B with the chunk is #7, so it will generate the hash strings faster. Now run this test method again. Run. You see, it prints the hash value of the password Java 2020 here. So if you want to customize BCrypt algorithm, you can use different constructors in the BCrypt password encoder here. You can see its source code to explore how it is implemented, and you can see this BCrypt password encoder uses the BCrypt class. This is the implementation of the BCrypt algorithm in Java. It is very technical details of cryptography. So if you want to understand how it is implemented, you can see the source code of the BCrypt password encoder and related classes. Now I show you how to use BCrypt password encoder for authentication in a Spring Boot application with Spring Security. So in the Spring Security configuration class, you need to declare bin of type password encoder and return a new instance of the BCrypt password encoder here. If you want to customize a BCrypt password encoder, you can use another constructor. And you need to set a password encoder for the authentication provider. Yeah. So that's it. Very simple to use BCrypt password encoder in the authentication process of Spring Security. And to use BCrypt password encoder in a business or controller class, let me show you. Here in the services class here. Yeah, you can the encode password method here. You can create a new instance of the BCrypt password encoder and invoke the method encode to encode a password. Yeah, and you can also tell Spring Framework to inject an instance of password encoder here using the auto-while annotation here. And then the code we use the injected instance of the password encoder here. It uses the matches method here. So that's how to use the BCrypt password encoder in the Spring Boot project. So far I have shared with you some interesting information about BCrypt, secure password hashing function used by Spring Security, and how to use the BCrypt password encoder in the Spring Boot project. I hope you found this video helpful. Please subscribe to my channel, like, comment, and share this video. Thank you.